So hello guys, what's up? We are back again with another question from our challenge series. And today our question is shortest path visiting all nodes. In this question, we are given a graph and we need to find the length of the shortest path that visits every node. Yes. So we need to find such a path which is shortest as well as it visits every node. Now, condition is that you can revisit nodes multiple times and you may also reuse edges. So yeah guys, let us see how we can solve this question. Now, what comes to your mind when you first listen about shortest path? Yes, it is Dijkstra. So we can actually think something in line with Dijkstra's algorithm or BFS in general. Now the graph is undirected as well as every weight as well as it is unweighted. So that is also an advantage to us as we can keep track of distances because we can be sure that when we are going from one node to another, then the distance always remains in an incremental order. Okay, we shall see what does this mean. So for example, if we do the dry run for this, so I can start from 0 or I can start from 1, I can start from 2 or 3. So for example, if I start from 0 and I go 1, now I can go back. Yes, I can go back to 0. So I need to make sure that I can go back. But I also need to make sure that this doesn't happen, that 0. Okay, so I am stuck here. 0, 1. So I am doing to and fro. I am doing to and fro. Yes. 0 to 1, 1 to 0, 0 to 1, 1 to 0. Because I can visit, so I am doing, it will stuck us. It will make us stuck into an infinite loop. So I need to figure out a way, such a way that I can go back as well, but I can have a unique path. I will have to have a unique path. Yes. So this comes handy with the technique of masking. So we will use a technique of masking to prevent this. So what will be our approach? Our approach will be applying BFS using all nodes. Yes. We will consider initially all nodes starting as starting. So we will insert all of them with distance 0 and then apply BFS and then apply BFS and then we will make sure that we traverse all the nodes and return the minimum distance. So let us see how we can do that through the code. Just a second. So yes, what is this? We know that the nodes are from 0 to, yes, so if there are 4 nodes, then 0 to n minus 1 is the are the nodes, actually are the nodes. So what we are trying to make, we need to keep track of the path also as well. So we are trying to use masking for this. For example, what is this int all is equals to? This will be 1 1 1 1. Yes. So I will try to have such a configuration that if I visit a node, if I visit a neighboring node, then I bit mask it. Yes, then I bit mask it. Initially, I will be having all zeros, all zeros. Yes. So then I will bit mask it with 1. For example, uh, just a second. For example, if I am Yes. If I started with 0 and then I visited 1. So I will mark 0th bit. I will mark 0th bit as 1. And then when I am visiting 1, so I will try to mark this bit as 1. Now I can again visit 0 because masking at this time, will be at this location will be this only. But now I cannot go back. Now I cannot go back because then this configuration will regain, because I am again going 1. So this will become 1 1. And this is already visited. This configuration is already visited. Hence, what we are doing, we will omit this. So in order to keep track of the visited, we need two things. We need the node as well as the track of the nodes from which it is coming, so that I do not repeat the path. I can repeat the node, but I should not repeat the path. And for that, we will be using a set. Now, set is used because it is easier to retrieve. It is in time complexity. It is better to retrieve elements to check whether there is a element present or not. It is better to use a set. So I will now very quickly walk you through the code. So we are generating this. Our target is this. If we achieve our target, then we can simply return. Yes. So what will be our queue storing? Our queue will be storing value of the node and again a pair distance as well as the mask value. So I will need to have the mask value, a pair, a distance, and of course the value of the node. And what will be my set having? My set will be again having the value as well as mask. So initially I will insert all the values, all the nodes into the queue, and I will insert in the set all the values and their mask. So mask is nothing but 1 left shift times the node, the ith, let's say 0. So 0th bit will be 1 for that. So this is very simple. Now we are applying simple BFS. Now, since the distances are not changing, since the distance between any adjacent node is 1, so we can simply use a queue, and we even need not check the distance condition. Yes, let me tell you. So we will pop from queue. As we do, we will take out all the parameters of the front node, value, distance, and mask. Then we will traverse its neighboring nodes. We will calculate the new mask. And if the new mask is equals to all, which we require, then we will simply return the distance plus 1. If this new mask and this neighboring node pair already exists, then we need not push it back into the queue. We will simply continue. Else what we will do, we will push into the queue with distance plus 1 and we will insert into the set. So yeah, guys, this was the question. Okay, so why we are not checking the condition? Because it is a queue and we are inserting all the distances with 0. Now these will come out, and at the back we will have distances with 1, then 2, then 3, and so on and so forth. So we will not have variable distances, means we will always have minimum distance at the top. So we need not take tension about that. So yeah, guys, this was all from this question. Thank you so much, guys, for watching this video. Make sure to hit the like button, press the subscribe button, and share it with your friends. Thank you so much, guys. We shall see you next time.